Hello, I'm going to do a quick teardown video today on a bit of a retro kit that I haven't seen around for ages and ages. Someone sent me it, so I figured I'd take it apart and have a look and see what's inside. I thought while I was at it I might as well do a video. A while ago I think Dave done a teardown on one of these things, which is one of the first series of handheld mobile phones. And I remember very distinctly having one of these. I think it cost about £3,000 at the time, and really nice phones at the time. You know, there was just after they started putting car phones into, you know, the big heavy car phones. And they had the ones that were like bricks that you could walk around with, and then these things came out, which were like a handheld brick. And one of the problems with them, of course, is it's a simple LED display. This doesn't work, so I can't show you it. Simple LED display, and you couldn't really hold much information. So the notion of having your phone numbers, which of course is commonplace today, just, you know, I think you could have like 9 or 16 or something, but then you had to remember that, you know, your number X was at position 4 or something. So they were pretty useless from that point of view. And of course at the time there was a term kicking around which I'm sure many of us will remember, called a yuppie, young and up and coming. And so these things were augmented by these things, which are what a sign organizer. Now these things, when they came out in 1983 or 84, were, you know, quite bleeding edge bits of kit. Really, it was the first sort of mobile computing, and this is arguably the world's first PDA, portable data assistant, they used to call them. And you know, if I'm completely honest, they're next to useless. Actually, I mean, they couldn't do very much. And in the end, these evolved into becoming. They used to make attachments for them. If you see, there's an expansion port at the top here. They used to make attachments here for scanning barcodes, and they ended up being more of a commercial tool rather than a personal assistant tool. But for a couple of years they ruled the roost, and PSION, which is a UK company, of course, went on to make the Sign Organizer 3, 4, and 5, which were really the first, you know, the forerunners to the well, they were the PDAs. They were the first PDAs around. This thing remarkably still works. I'm quite sure. Let's see if I can remember how to use it. Okay, so you know, you couldn't do much with it. It had a calculator or you know, some sort of concept of a spreadsheet, a diary, and of course phone numbers. And if I'm honest, it was completely terrible. But you know, for what was around, that was all there was. Now, for those of you that don't know, the PSION software, the software that was made by PSION, eventually went on to become the phone operating system that they use in Nokia phones. It's the Symbian operating system. So this is kind of the history. This is the starting point for all of that. So you know, there's definitely a point in time in history, in technology history for these things, and it'll be interesting to see what's inside them. Now the other thing, obviously because of the date that these things were made, there wasn't really much in the way of memory. And so what PSION had done is they'd come up with these data packs. And if you look at them, these are basically the blanks. And inside there's a really simple sort of combination serial parallel interface, which we'll have a look at in a second. But these data packs, you could buy, you know, RAM packs, or data. They called them data packs, which are kind of permanent storage. You could turn the power off, and we'll have a look inside these in a second. You could also buy, I can find them. The way you'd get extra applications for this thing was to buy them in these kind of format. Hopefully that will focus. There you go. This is the spell checker. So these things would basically plug into to here, and then, you know, you would have your various combination of data packs and or applications, but obviously pretty limited. Anyway, what I thought I'd do is have a go at tearing this down, having a look inside, see what's in there, just remind us of all of what technology used to be like. What's that, 85, 95? Oh, 25 years ago. Very long time ago now. Actually, no, 30 years ago, in fact. All right, so let's I'm going to reposition the camera, and then we'll take these to bits and have a look and see what's inside. Just another thing on these phones. These old phones were basically analog phones, so they worked on the analog network, which now, of course, is completely defunct. I'm not sure if you could you could probably convert these to talk to each other or do something with them. I'm no RF expert, so I wouldn't know, but they're long since defunct. But Motorola were also the first company to produce a digital phone, and actually, this is their digital phone. You can see it's slightly smaller. When I say digital, GSM is what I'm talking about. This was the first ever GSM phone, and you can see that the way you can tell that is that in the back here there's actually a place for, if I can get it out, for a classic SIM. So I'm led to believe that if you, I haven't tried this, and I doubt I'll bother, but if you're in an area where there's a 900 megahertz GSM network still in operation, these phones will actually still work.
Bizarre.
Okay, so let's take this apart. So I think this comes off easy enough. It's just a plastic moulding, nothing special about that. The battery compartment, it runs off a PP3, a standard alkaline PP3 battery, and just take it out like that. There's kind of a, I don't know if you can see that, kind of sprung-loaded plate that it presses against. And there you go, made in the UK. Very rare thing to see nowadays, but certainly back in the day, we were quite good at this sort of stuff, at least at the starting point. There's a third screw here. Okay, so there's a sounder there, a couple of springs, brass springs, just to make the connection. Okay. So 2 boards, very classic 80s construction, although surface mount components were really only just starting to get used, so this was, for its time at least, quite bleeding edge. Well, there you go. I'm not sure that's ever going to work again. So as I've pulled that back, I guess that wire's brittle. That's actually just broken away some of those connections there, so I'll have to, if I want to get this working again, I'm going to have to remake those connections. There we go. Oh, broken. Never mind. I wasn't planning to put it back into use, so let's have a look and see what we've got here. Let me bring the camera in a bit closer. Okay, so all surface mount devices. That looks like some kind of transistor or regulator there. Yeah, transistor by the looks of it, because it's got another transistor driving it, all hooked up. What else we got here? Oh, sorry, LM324. I think this is the. I'm sure. I think that's the contrast of the display. That's what that does. There's a little bit of corrosion just right in there, by the looks of that, and right on that that resistor there. That needs cleaning up. TI. So where are we? LM324. What do we got here? This one. BCOA. Not sure what that is. Texas Instrument parts. We'll go and have a look and see if we can find out what that is. Nope, no idea. Can't find any information on that part. The other parts here are a 4093. I think that's a quad NAND gate, Schmitt trigger input, and 4011, which is also a quad NAND gate, non-Schmitt trigger input. So this sort of looks like power supply and some basic logic, and of course the interface here probably. The expansion port probably just makes its way around straight to the main logic board there. Okay, so let's have a look in here. So the microcontrollers that these were based on, which I think is probably that one there, is a Hitachi 60. Oh, there it is. Actually, that's the microprocessor here. This is an Hitachi 6303, which was basically a faster 6800 chip, more fully integrated, so had more integration on board, so it was more compact to use, and that was I think in this one it runs just under 1 megahertz, the processor speed. These chips here are LCD drivers. That's obviously driving the LCD display, and that's the LCD controller 66780. So this is some of the forerunners probably to the common LCD. This is a 4x20 display, so this is probably the forerunner to those LCD interfaces that we all know and love nowadays. Let's have a look and see what the chip is. Okay, from the looks of it, that's a semi-custom IC. I think it's IC4. I just found a website where there's a technical manual that details how all this stuff works, or what the details are, or at least describes all the electronics, or all the major components in there. So I'll put a link to that in the blog down at the link will be just down at the below the video here. For the supporting blog page, I'll put references to all the information that I find. These two chips here are, as you can see, 8027C256s. These are Cmos Eeproms, one-time programmable Eeproms. I think they're one-time programmable. I'm guessing 27C256. Certainly the ones that I knew back in the day had a window to erase the EEPROM contents. These obviously don't have that, so I'm guessing that they're one-time programmable. Anyway, they're EEPROMs. They've got the firmware on them. This is a static RAM chip, 62256, so simple SRAM, and as I say, just display controllers, crystal, and really nothing else. Let's take this out now. I've actually broken the thing. Let's strip this board out. Okay, so well, those will be fun. Okay, so those buttons are just resting in there. So if I drop those, it'll take me an age to put them back. So let's just leave that there. Very classic rubber button construction, and the display. Seems to be just clipped on here. Oh well, in for a penny, in for a pound. We rendered it useless. Let's have a quick look under here. Oh, I'm going to regret this. Okay, yeah. So this has those rubber pads, those rubber conductive pads that conduct through. Horizontally through or vertically through, and so that's obviously connecting the glass directly to the board there. You can see. Okay, all right. So that's it. That's it for this. There's not much in there. I'll need to put that all back together. So let's get that out of the way. Now let's look at these data packs. So this is a 64K data pack. And one of the quite hilarious things about these were, as you can see, it's basically an EEPROM. So what would happen is you'd add your contacts or create your spreadsheets or whatever you're doing. You'd write them to these data packs, which of course it would keep them. But the only way you could erase them to reuse them was to remove them from here and expose them to ultraviolet light, which is quite interesting. I'm not quite sure how non-technical people that were using the PDA, perhaps as an executive tool at the time, were going to get their heads around doing that sort of stuff. But there we go. So the obvious thing is, these EEPROMs have a 13, 14, 15-bit address bus and an 8-bit data bus. Of course, these are all parallel from the 80s. But you'll notice that there's only how many connections are here? There's only 1, 2, 3. There's only 16 connections on this expansion bus, and what they used to do is use 402. I think that's a 4024 counter chip, and you can see the part numbers there on the 4024 and 4040. These were counter chips, and they basically drive, I think the address bus was driven as a serial input. So what it would do is it would reset the counter and then pulse the counter to get it to the address on the EEPROM that it would want. And I think it was pages, so I think this was the page address, and then there was probably 4 bits were dedicated to select the page or something like that. I'd have to read the details. It's something like that anyway. So you could select the page and then reset the counter and then read or write the page sequentially. That's how they worked basically. And obviously this the power supply in here, this thing here, I'm guessing that looks like an inductor. So I'm guessing this, because these EEPROMs of course needed, I think it's 12.5 volts. Actually, it says it on them. So this was bleeding edge. So it used to be EEPROMs needed 21 volts on their VPP pin. So you need to raise that pin to 21 volts, and then you could program them. And programming them was actually quite slow. And I guess this thing would generate the 21 volts needed. That's probably what all that drive is down there, just to generate the programming voltage for the EEPROM. So that's what's that? So that's a data pack. Let's have a look at these other ones, see what we've got. Okay, so spell checker. This is an application, so it's going to be no surprise at all. It's probably just going to be less easy to get apart for a start. Okay, so quite predictably similar sort of setup, but this time a once only programmable ROM containing the actual firmware or the program to run the application. What else we got here? This is another variation. This is a RAM pack. So from what I recall, these also retained data, but not guaranteed permanently. And the reason for that, I guess, is yeah, it's battery backed. So what this is a static RAM chip. Let's see the number on there. 58256 static RAM chip, 120 nanosecond access time, and again the 2 counters and pretty much the same logic to access it. On the back here we've got a battery. I wonder if that's any good. I very much doubt it after all this time. I'm highly surprised if this battery had anything in it, to be honest with you. I'm also highly surprised it hasn't leaked all over the place. There must be a good quality battery. Yeah, nothing. So I guess it's lost its data. Okay, so that's what the RAM packs look like. What else have we got here? Data pack. RAM pack, finance pack. So I guess that's another application. Let's just have a quick. Okay, that's interesting. So this application was actually done on an EEPROM. So yeah, slightly different configuration. All right, there we go. So I've now rendered this lovely piece of retro kit completely useless. I think I'll have to put it together and make it work again. Okay, to make the repair, I couldn't strip the ribbon cable that I've broken. So what I've done is I've just grabbed a string of resistors like this, because it just so turns out that the spacing of these resistors is 0.2 of an inch, and this is a 0.1 inch pitch here. So what I've done is I've just cut enough leads off of a resistor like that, because what I needed was just this, just to hold it in place. So I've soldered those. I'll cut those now, offset those one by one, solder those, and then the aim of the repair then, it will be a one-off, because unlike before where you were able to open this and fold it out, what I'm going to do is I'm going to have all those, I'm going to reconstruct the unit and push that down in over the holes there, and once it's screwed back in place, just solder it and trim it back, so at least it'll be working again. Okay, just had a look at this board with that little bit of corrosion, and it looks like both these electrolytic caps have spilled their guts on the board at some point. I've just scraped around, and actually the board does look like it survived. I'm going to have to tin these with solder and just make sure that they don't continue to corrode. But basically these caps have, you can see, have been leaking away, both of them. Yeah, okay, so it was kind of lucky this got torn down, because I don't think it would have survived much longer. That was still slightly damp there, so I guess those things are still leaking. Okay, so there we go. It's all back together again, working as it was. No idea what to do with it. Completely useless. I was thinking, is it worth hacking? Could you do something with it? Could you make something out of it? But what would you do with something like that? I have no idea. If anyone's got any ideas or suggestions, please feel free to leave comments. I found a few websites referencing this and some technical manuals and that kind of stuff. So I'll put all of that as links in the supporting blog page, and you can reach the blog page just by clicking on the link just below here. That's it. If you found that useful or interesting, enjoyed the video, please give it a thumbs up, and I'll catch you next time.